So to start things off, we notice that the cheese has a cylindrical shape. We know the moment of inertia for a cylindrical shape, which is I is equal to 1/2 mr squared. We also know that the cheese is rolling, so we know that there's going to be both translational and rotational kinetic energy in this. For linear or translational kinetic energy, the equation is 1/2 mv squared, and for rotational kinetic energy, it is 1/2 I times angular speed squared. Looking at the moment of inertia for a cylinder, we know that we have to substitute that in for the I. The 1/2 stays the same, in which we're going to put it on the outside. Then we're going to substitute the I with the 1/2 mr squared. And then to find angular speed, we can use the simple equation of angular speed is equal to velocity over r. Don't forget to include the squared. We notice that the r's actually will cancel, so this means that when we add the translational and rotational, we actually are adding 1/2 mv squared plus 1/4 mv squared, which gives us 3/4 mv squared. Since the cheese is stopped at the top of the hill, there is zero kinetic energy at this moment. But we also know that there was no loss of energy since there was no slipping involved. This tells us that the energy was conserved, so we are actually converting our energy from kinetic to gravitational. So we are going to set 3/4 mv squared equal to mgh, which is our gravitational energy. We notice that the masses actually cancel out, leaving us with 3/4 v squared is equal to gh. G is our gravitational constant, which is 9.8, and h was given to us in the problem, which is 1.52 meters. We get around 19.86, and we can square root this to get our velocity on the linear terms, which is 4.46 meters per second.